Now, let's go to the cell line. Growth in suspension, no aggregates. Almost every process today is so that the cells grow in suspension. However, aggregate formation, cell aggregate formation is still by some process the case. The aggregates can be in small scale and large scale different, the size of the aggregates. And the size of the aggregates influence also the metabolite utilization. And therefore, if we design a process, it is better to design a process with single cells, which don't form aggregates. Growth in protein-free medium. The topic today is scalability, but I am speaking about protein-free medium, what that means. That means if I have a cell line which grows in a protein-free medium, by media filtration, I don't need to think about protein retention on filter. Many cell culture media today contains proteins, IGF-1 or insulin at least. But we know that these proteins can be retained on filters, media filters. In some filters more, in other filters less. But if I have a cell line which grows absolutely free in protein-free medium, then I don't need to think about that. And in small scale, when we get more insulin in our culture medium because the filter didn't retain very much insulin, later on in 10,000 liter, we retain a lot of insulin by media filtration, and the cells produce small scale 2 gram and large scale 1.5 gram, we don't have KLA problem. Predictability. The cell line should be predictable. The cell line is not allowed to make surprises. I will show you what that means. There are many cell lines which make surprises. Surprise means unstable process later on in large scale. High growth rate is always better. I mean, very slowly growing cells, everything is fragile, and let the cells grow higher, and if they have high growth rate, you get high titer, and also the scalability problem is indirectly solved, actually. Long-term stability. I am not speaking about genetic stability. I am speaking about cell line stability. That means when I culture the cells over long term, and this cell line should not change its attitude later on. What that means with concrete data, here we have CHOK1 cell line. We have cultured the cells for 75 passages, every passage 3 days. That means over 200 days. Here we use serum. Later on, this cell line is adapted on serum-free conditions. What we see here is, even though every 3 days we split the cells with the same inoculation cell density, the cell line makes surprises. It goes up and down, goes up, down, down, up. That is horrible for large scale. First. Secondly, now I go back. Long-term stability. I mean, the cell line is more or less adapted here on serum-free conditions. From there, cell line don't grow in serum. But if we take a cell line from here for inoculation of production bioreactor and take another cell line, no, not cell line, but aliquot of inoculum, and inoculate the production bioreactor, is this cell line still the same like there? I would say not. There is a change. And the metabolism of the cells there and there is very likely different. And if you fix your process with a certain medium, and your medium might not be suitable for that clone there instead of there. Now, that was a worst case scenario. Here we have a best case scenario. We have taken the same horrible CHOK1 and optimized the cell and the conditions, and then cultured again 240 days long. Every 2 days, we have subcultured the cells. And what we see is cell line doesn't make surprise anymore. Now we have the basic. Now we can take these host cell line for transfection. Now we have a good feeling that we will not have a scalability problem, first. Secondly, it is likely, but not guaranteed, that the cell line here and cell line there have still similar or same metabolism. At least I don't see a shift. In stock culture, normally we see that cells grow higher or whatever, and here we don't see it. Third, what were the criteria actually? The criteria were predictable, and the optimized process we have seen the stock culture is predictable. Growth in protein-free medium and long-term stability and high growth rate. We can see here everything. We see the cell line is grown in a serum-free, protein-free, growth factor-free, and peptone-free, 100% synthetic medium. And the cell line has a doubling time of 14 hours, which grows fast. And this work has taken 2 years. And after that, that is still host cell line. After that, we said, OK, now we have a good feeling that scale-up problems probably will not happen.